All right, this is video 8.2. The unit title is Shadow Proofs. The objective is I can determine the area of a given figure. And your Excel skills, there are 3 of them, and you want to try and work on these now so that when you come to class, you have some of them done. S5, S6, and S7, and these are out of geometry. All right, let's go flippers. So the question that we want to think about today is what is area? Okay, what is area exactly? And our definition for area is going to be pretty straightforward, and that's going to be area is the number of square units enclosed in a figure. And by the idea of square units, I mean if I have a square, okay, that's 1 by 1, I'm looking for how many of these 1 by 1 squares can fit inside of any figure. So let's actually look at this square here, okay? So let's say we have a 1 by 1 square. And we want to know what the area is of the figure to the left. So the area of this figure, if this is a 4 by 4 figure, then that means there are 4 rows. I'm making columns right now. There are 4 columns and 4 rows. Again, columns go up and down vertically and rows go horizontal. And in order to figure out the area, I need to actually literally count how many of these 1 by 1 squares are inside of this figure in this particular 2-dimensional area. So let's actually look and count. So we've got 1, that's a 1 by 1. We've got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's actually 16 squared units, and we write units squared. Now, I know some of you are thinking, well, Marla, I could have just multiplied 4 by 4, and I would have gotten the same answer. And you're right, you could have. But again, the idea, the concept behind area is that you really are counting these boxes inside. And this number tells you how many of these boxes are going here horizontally, and this number indicates how many of these boxes are going vertically. All right, so let's look at another example. So now we have a different figure, and this figure is actually a triangle. Now, the strategy we used a moment ago, we necessarily can't use that here because the other figure was a rectangle or a square. Now, let's think about something. I know this is a triangle, and I know if I were to create the same side here and give this of length 8, and then another copy of the bottom there, then I would have 9. And if I do that, I can use the same strategy I used before, which was this means that this is going across here, and this is cut into 9 small boxes. So 1, 2, 3, 4, 5, 6, 7, 8. So that means I'd have 1, 1, 1, 1, 1, 1, 1, 1, and 1. And then this way, I would have 8. 2, 3, 4, 5, 6, 7. So 1, 1, 1, 1, 1, 1, 1, 1. And I could fill this thing all the way in, all the way over here with more boxes. But I know, again, because this actually works, that I can multiply 9 times 8. And then I would get 72 units squared. Now that would work, but I don't have the entire box. I don't. I only have 1/2 of it because these 2 triangles are congruent. Therefore, the area that is not a part of this would be 1/2 less than what I have in the image. So that's going to be 72 divided by 2, which is going to give us 36 units squared. And what this brings us back to is this idea that the area of a triangle, because you can always, with a right triangle, and it's very important that you have a right triangle, because again, this is going to give me my altitude, and altitudes come from right angles. So here's my big fat right angle right here. And then I also need a base, and here's my base. So my base here is going to be that 9. So here's my base, and I'm saying the altitude, the area of a triangle, we'll make a little triangle there, is going to be the base, which is 9. And then I need to multiply that by the height. And we talked about in order to find height, you have to have an altitude. And this is that altitude. That altitude gives you the height. So base times the height is going to be 8. So 9 times 8. And then again, what did we do because of our picture? We said, well, this would have worked. I could have multiplied the 9 by 8, but that would give me the area of this entire square. I only have this triangle. So I'm going to take that whole thing and divide it by 2. Divided by 2. And then we worked it out here. All right, let's look at question number 1. So question number 1 says, find the area of the figure below. So here's the figure, and let me give you a number here. This is 9, and this is 6. Now, the area of a parallelogram, and that's what this is also going to be our base times our height. Okay? But again, we need the height. This figure's height comes from the altitude that you draw here. So you have to have a segment that goes from the bottom to the top at a right angle. And if you do, you can use that as your altitude. So this is going to be our height. Our base is 6. Very clearly, our base is here. And our altitude, which gives us our height, is 9. So that means this figure's area will be 54 units squared. Number 2 is circle. Remember the circles? So the diameter of a circle is 10 kilometers. What is the area? So they're telling us the diameter here all the way across is 10. And we know for the area of a circle, it's one of my favorites, is going to be when we take pi and we take the radius and we square it. Okay? So if I take the radius, which I know has to be 1/2 of the diameter, so that would be r equals 5, I can plug in a equals pi times 5 squared. And that's going to give me 25 pi. I just switch that around. And then this is going to be units squared. Okay? And we're going to leave this as our answer. Number 3 says, what is the area of triangle ABC? Now, triangle ABC, I know a lot of you just want to say, hey, I know what this length is from A to B. And you probably do know what that length is. This number, if you can't read it, and some of you probably can't, is an 8. So it starts at 0, goes to 8. You're right, that dimension is 8. But I'm not exactly sure what the dimension CB is, what the length of CB is. And you could find it using Pythagorean theorem. You could also find the length of AC using Pythagorean theorem. But there's something else you could also do here. You could think about the idea of us creating, like we did before, creating a figure that you definitely know the area of and taking away those two. So let's actually enclose this into another figure. So what I did here is I actually took the original figure that I had and I enclosed it inside of a rectangle, which I can easily find the area of. So let's do that. So this figure is going to be a 5 by 8. And we can see those two figures. So we'll say that the area of the rectangle that we drew is 8 times 5, which gives us 40 units. Now, we want to figure out how big the rectangle or the triangle here is that I'm shading in, and this triangle here. And if we find those two triangles, we can actually subtract them from this larger area that we found, and then we'll have our remaining area will be that original triangle that we were looking for. And remember, we're doing this because the triangle that we have is not a right triangle, and we don't have an altitude for it. Now, we can use our formula for a triangle for this triangle here and this triangle here because those are right angles. They have altitude. So let's do that. The area of this bottom triangle here, okay, is going to be 1/2. So we've got a 2 by 5. So that's going to be area equals 2 times 5 divided by 2, which gives us, and that's a times, big times, that's 10 divided by 2, which gives us 5. So that one is going to be 5 units squared. And then let's do the top triangle, which we can see is also it's going to be 5. And over here, this would have to be 6 because this is 2. We see that. And we know the whole thing is 8. So this has to be 6 So that's a area equals 5 times 6 divided by 2. That's going to be 30 divided by 2, which gives us 15 units squared. So now remember, we had 40. We started off with 40 here. So we're going to take our 40 and we're going to subtract 5 and 15, which would be 20, and we're going to have our answer of 20 units squared. And that's our answer, okay? And again, it was not a right triangle, so we had to build a box around it and take away the areas of the right triangles to find what we needed. Here's a secret hot question. It says determine the area of the figure below. So you're probably looking at this figure and you're like, what? This is insane. It's not. Think about what you see. Remember, you can cut this up into smaller pieces. You can see that this is 7 by 9. And you can see that this is 7 and this is 9. Think about how you can do that here. Think about what you can do to divide this up into smaller pieces. See you tomorrow.